Okay. And in 38 on page 204, we have natural log of e over 5. Perfect. So one of the properties states that natural log of a ratio is the same thing with a difference of two logs. Log of the top minus log of the denominator. So this is property 2. And we already established that this is 1. So the final answer is 1 minus natural log 5, and they're giving us natural log 5 because they don't want us to use the calculator. So they're giving us natural log 5 as 1.6094. So 1 minus 1.6094. So this will be negative 0.6094. That's all we need to do. Okay, moving on. Round to the nearest, run the answer to the 3 decimal places. Fine. So let's see how we solve any of these. Anyone would like to choose 39 through 50?
You do 48.
Yes. Perfect. 48. Where are you? 48. Perfect. Good pick. 8 e to 3t equals 25. Excellent. Good. Very similar to what we just did a few minutes ago, in anticipation of this, if you want. So, what will be the first step? Of course, this is an exponential equation because the variable is at the exponent. So what will be our first step? For sure.
Divide by 8.
Absolutely. Thank you. Thank you very much. So e to 3t equals 25 over 8. Don't bother with this number. It's just a simple number. We don't care. What will be the next step towards solving for t?
The natural log.
Very good. Excellent. We apply natural log to both sides. Why? Sorry, I'm losing my voice. Because only the log allows us to bring this in front. So we get 3t. I should write times natural log e. But what do I know about natural log e? How much is natural log e? What does it equal to?
1.
Yes. So you can forget about it. So this is natural log of 25 over 8. And final step towards solving for t. What do I need to do? Drink some water, but then?
Divide by 3.
Of course. Of course. So natural log of 25 over 8 divided by 3. That's it. Done. So they want 3 decimal places. Fine. So natural log 25 over 8. Do not do this step by step. Please put everything together. Make sure you have enough parentheses and it makes it sound and perfect. And just press enter. So then t equals 3 decimal places. So because this is 8, I have to increase this by 1. So then I have to increase this by 1. So 0.38. So t equals 0.38. And that's it. And that was solving the exponential equation. Okay, now the next step, 51 to 60. This is an important situation because if you remember, we looked at the domain of rational functions. We looked at the domain of radical functions with an even index. Now, because this is the third function with problems, we have to look at the domain of log functions. Okay, so let's choose 51 through 60. Allow me to choose one, and then you can choose the next one. I would like to choose 55. And then you choose the next. This is page 8. Perfect. So 55. And this is on page 204. Y equals natural log of x plus 3 plus natural log of 5 minus x. So I'm asked to do nothing to the function. I'm only asked to find its domain. And I know that the domain of a log function is 0 to infinity. But this is for this simple function, which is f of x, natural log x. This domain refers to natural log of x alone. But here I have a function that has natural log of x plus 3, and here I have a function that has natural log applied to 5 minus x, which means this quantity has to be strictly greater than 0. And it means that this quantity has to be strictly greater than 0, not equal to 0, because there is a vertical asymptote here. It's open. So I will have to solve the first inequality, which is greater than -3. I will have to solve the next one, but careful how you solve the next one. It's better if you move x here and read it from the right. X less than 5. It's up to you. You can move 5, multiply by -1, but then you have to switch the inequality symbol, and that's where you're getting anyway. But now what do I do? How do I select what's going on here? Here's how we do it. The best thing to do is just present what you have on the number line. Greater than -3. I don't need units here. I just want to represent and make it clear. Greater than -3 is this. Less than 5 is this. In order for this function to exist, both functions have to exist. Because if this one is undefined and this one exists, I cannot add something to undefined, or vice versa. So both functions have to exist at the same time. So then, therefore, what will be the domain of this function, y, which is the sum of two logs? What do I pick?
-3 to 5.
Absolutely. It's the common area. Thank you so much. Common area. And this is it. This is the common area where I see both colors. Meaning, only in here, both functions exist at the same time. Here, only one of them. Here, only the other. Who cares? They have to exist at the same time in order for the function to exist. Good. Any questions? Any questions? Okay, finally, let's also look at some logarithmic equations. So this was an example. If you want to work on more, let's do that. But I also wanted to add, arrive to word problems, because that's why we're here. These are the basic steps, but I want to present word problems to you. So, would you like to choose something else? Would you like to move on to log equations? Anyone, please? Do we need more examples from domain? No one wants to talk to me tonight?
I think we can move on.
Okay. Okay, what about from 61 to 68? Solve each logarithmic equation. Do we need to review that? Would you like to choose?
we do 67?
Excellent. That's exactly what I was gonna say that I was looking at. Natural log of x plus 3 plus natural log of x minus 3 equals natural log 7. Perfect. Very good. I would have picked that if you didn't. Okay, perfect. So I look at this equation and I see two functions that have restrictions. This function exists only if x plus 3 is greater than 0. This function exists only if x minus 3 is strictly greater than 0. When I solve this, greater than negative 3. When I solve this, greater than 3. What is the common territory? What is the common element? Where are the common elements here? If you need to graph it, we can graph it. So 0, negative infinity, infinity, greater than negative 3, and greater than 3. Where is the common territory?
Um, 3 to positive infinity?
Excellent, perfect. So what am I saying here? And why am I doing this? You have two options. You can go ahead and solve the equation, but you have to check the solutions. If you forget to check the solutions, it's incorrect. Or you state the domain from the very beginning, as we just did. You get to the prospect solutions and you say, are the solutions or is the solution in here? Good. If it's not in here, it cannot be accepted. I recommend this method. But again, you can solve the equation, but make sure at the end you go back to check. Okay, so we established where the solution should be. If there is a solution and it's not here, it's not the solution. Good. So now coming back to our equation, I will write it again. X plus 3 plus natural log of x minus 3 equals natural log 7. Now I'm going to go back to the properties of logs that we wrote a few minutes ago. 1, 2, 3. Because these properties are dynamic. What am I meaning by that? What do I mean by that? Well, this changes into this, but I can also go backwards. So I can write, if I'm given this, I can write this. If I'm given this, I can write this. And I need to condense it. So how do I condense this piece based on property 1? So I have this, and I want to write this. And this is the sum of two logs, of course, the same base, natural log, natural log. How do I condense it so I can move on? Can anyone try?
Natural log
Yes?
3 times negative 3.
You cannot separate anything. This is one piece, which is A, and this is the other piece, which is B. We cannot separate anything.
Would it be x plus 3 and x minus 3?
Yes, times, indeed, which is this. Has to be the
And then
product.
over 7.
We're
divided by 7.
not there yet. You'll see in a moment. Okay, perfect so far. That's all I needed. Perfect, thank you. Now, here's my next question. I have two logs. They have the same base. Do you think that I can have here 1,000 and here 300 if they are equal and they have the same base? Will natural log of 1,000 equal natural log of 300? Is it possible?
No.
No. Do you think I can have here 15 and here 9? Will that be possible?
No.
No. So then what has to happen with these two quantities? Because this is equal. This equals that, and they have the same log. So what has to happen to this quantity and this quantity for this to work? Anyone, please?
Do they have to be the same?
Absolutely the same. So x squared minus 9 must equal 7. There is no other way. There is no other way. If this quantity does not equal this quantity, the two logs can never equal each other. So this is x squared equals 16. And give me the two solutions, please. We move negative 9 to the other side. You either factor if you want or take square roots. And what do we get? Please, anyone?
4.
It's quadratic. You have to give me two solutions.
-4.
Good. Now, what do you think?
4 is the only one in the domain.
That's it. So we solve the logarithmic equation. The only solution is 4. Of course, if you want to check, you can. Very easy. So natural log of 7 plus natural log of 1. I don't even need a calculator. Because natural log of 7, natural log of 1 is 0. Natural log of 7 equals natural log of 7 when you plug in 4. Okay, finally, let's get to where we're really, really going. Okay, applications. So now we have all the information we need to look at applications. So let's start with this 169, and then I'll let you choose the next one. Okay, so U.S. travel exports. U.S. travel exports, goods and services, and so on and so forth, are increasingly exponentially. How do I know? I'm looking at this function, a constant e to a positive number times t. So I'm going to copy. So this is 69 on page 204. So I copy v of t, the value of t, years after 2011. So t's time, t equals 0 represents 2011. Okay? The moment I'm told t's time after such and such year, I write immediately that this signifies t equals 0. Okay? Then I copy the model, and the model is 115.32 times e to 0.094 t. Okay. V is in billions. So I make myself a note, billions. Okay, perfect. Okay. Estimate the value of US travel exports, which is V. Estimate the value of V in 2018 and 2020. What do I have to do? Please, anyone. So 2018 and 2020.
Figure out the years between
Excellent.
2011, 2018,
Yes.
and
So
from 2011 to 2020.
good. So 2018 minus 2011 is 7 years. So I need to find V of 7. From 2020, that's V of 9. You know what I'm going to do? I'm going to plug it in. Oh, I just didn't share. Sorry. Okay, I'm going to plug it in because I don't want to have to do this again. Although you have other options of copying and so on and so forth. I prefer to see the function. That's me. You develop your own style. E2 0.94t and close. And I get the answers right away. I want 7 and I want 9. Go and highlight to see what's in there. So 222.67 billions. And the other one, 268.73 billion dollars. Both. Okay. Then, when will the value of US travel exports reach 150 billion? What am I asked to do now? In part B. When will the value reach 150 billion? What do I do now? What do I do now? Anyone, please?
Do 150 billion equals
Excellent. 115.32 e to 0.094t. Excellent. Good. Perfect. What do I do now?
divide by 150?
Of course. And don't worry about that number. Perfect. Excellent. What now?
Would you take the log of both sides?
Absolutely. Thank you so much. Very good. Don't worry about this number. It's just a simple number. It looks fantastic. But it's just an eyesore. Times natural log e, which is 1. And finally, how do I get t? What do I need to do? To get t?
Divide both sides by 0.094.
Very good. Let's see what we get. Be careful how you put it in. The best way to put it compact, not step by step, because you introduce a lot of error, potentially anyway. So natural log and 150 divided by 115.32, close, and divide by 0.094. So when this is going to be t years since 2011. So 2.8 actually. So t is 2.8. So somewhere in 2013. So 2013 towards 2014. Okay, final question here. Where am I? Here. When will the value of Israel be double their value in 2011? This is the 2011. Because when t is 0, this quantity is 1. So this is the initial value in 2011. So when will it double? Okay, so we've done this before with the doubling situation. So in part C, so I have 2 multiplied by 115.32 equals, oops, this is no good anymore, sorry. So equals 115.32 e to 0.094t. Of course, I would divide both sides, and I get 2 equals e to 0.094t as we did before. Yes, we apply natural log for the both sides, and we divide natural log by the rate. That's it. I don't present the formula. This is a formula, natural log divided by the rate. I don't like to present the formula. I'd like you to understand where it's coming from. But you can use the formula if you like, of course. Divided by 0.094. Okay, so it doubles in 7.4 years, which means in 2018. It did double. If the model is correct. I'm assuming it was determined